Hi guys, welcome back. So today's question is number of ways to split an array. So we will be given an array nums. So nums is an integer array which contains n number of integers and n goes up to 10 to the power 5. Okay. So n can go up to 10 to the power 5. And we have for the first example we have 10, 4, minus 8 and 7. So what the question wants us is to find number of splits such that the first half of the split, the sum of the elements in the first half of the split is equals to or greater than the sum of the elements in the second half of the split. And we need to find out the count of such valid splits. So let's take the first example. If we split our array here, so this is the 0th index, first index, second and third. So the first half of the split, the sum is 10 plus 4, which is 14. And the second half has a sum minus 8 plus 7, which is minus 1. The first half definitely has a greater sum than the second half. So this is a valid split. Also, we can see if 10 alone is a valid split. So 4 minus 8 plus 7. It is the sum of elements in the first half is 10 and the sum of elements in the second half is minus 4 and 3. So this is again a valid split. So if we split after the third element, so if 10, 4 and 8 minus 8 are on one side and 7 is on the other side, then sum of the first half it would be 6 and sum of the second half is 7. So 6 however is not greater than or equal to 7. So this is an invalid split. So let's check how to solve this question. What the question actually wants us to do is split an array at the ith index and then sum of elements from 0 to the ith index must be greater than sum of elements or equal to sum of elements from I plus 1 till nth element. So let's say if we take the sum of elements from 0 to nth element, this would give us the sum of the whole array. So if we already calculate the sum of the array and store it in a variable called sum, so can we say at any given index I, the sum of first half would be prefix sum till I, and the sum of second half will be this variable which stores sum of the whole array, sum minus prefix sum of I minus 1. Because let's say this was the 0th element, this was the ith element, and this is the nth element. So I have sum which stores sum from 0 to n. And we also have another variable which stores prefix sum as we go on, as we iterate over the elements. So prefix I stores sum from 0 to I. So sum minus prefix I minus 1 will have the sum from I till n. So sum minus prefix sum of the previous element will contain the sum from ith element to the nth element. So first calculate the total sum for this array. the sum would come out to be 13, 10 plus 4 minus 8 plus 7. And we also maintain a counter called pre-sum, starts with 0. When we iterate over the first element, pre-sum is assigned as 10. So we are splitting the array this way: 10, 4, minus 8 and 7. And so this is the sum of S1, split 1, and split 2 would come out to be sum minus pre-sum, which is 13 minus 10, which is the sum of this part, that is 3. So this is a valid split. So we increase our answer by 1. Currently it is 1. Then we iterate to the next index. So the next split would be 10, 4 and minus 8, 7. At this point, our pre-sum would have value 14 because 10 plus 4. And the split 2 would have a value of sum minus pre-sum, which is 13 minus 14, which is equals to minus 1. So definitely S1 is greater than S2. So this is also an valid split. So our variable answer is incremented again, and the answer is now 2. And now we move to the third index. So the split looks like 10, 4, minus 8, and split 2 has 7. In this case, our pre-sum split 1 has a pre-sum of 6 because 14 minus 8 is 6, and the split 2 has a total sum of sum minus pre-sum, which is 13 minus 6, that is 7. So S1 here is less than S2, so this is an invalid split. So our answer variable would not be changed. And then we finally move on to the last split. So we actually don't move to the last element because taking 10, 4, minus 8 and 7 in one side and having nothing on the other side would not be a valid split. So we don't move to the last element. So our answer finally stores the number 2, which is our correct output. So we'll take another look at an example. So let's take the second example, which is 2, 3, 1 and 0. So nums has 2, 3, 1 and 0, and the desired output is 2. So calculate the total sum, which is 2 plus 3, 5, 5 plus 1, 6. Now iterate over each index. So let's begin with the first index. Split 1 has pre-sum as 2. Split 2 has sum minus pre-sum, which is 6 minus 2 equals to 4. So the first split is invalid, which is 2 and 3, 1, 0 on one side. So our answer variable remains 0. Now we iterate to the second index, and we'll have S1 as pre equals to 5. S2 will have sum minus pre, which is 6 minus 5, that is equals to 1. So the split looks like 2, 3 and 1, 0. So here S1 is greater than S2. So this is a valid split, and our answer is incremented by 1. So the answer variable now contains the value 1. We move on to the third index. So now S1 contains 6 and S2 contains sum minus pre, which is 6 minus 6, that is 0. Again, S1 has is greater than S2, so this is also a valid split, which looks like 2 3 comma 1 and 0 on the other half. So our answer variable again increments and finally has the value 2. And as I said, we do not move to the last element because the split 2 3 1 and 0 on one side and an empty subarray on the other side is not a valid split. So we stop the iteration on the second last element. And finally, our answer contains 2, which is the desired output. Thank you.